That movie? No. Oh. Yeah, that's too bad. You really missed out. You poor people. Yeah. The circle of math. What is the circle of math? I love the circle of math. Because let's say, okay, I've got this. Okay. What do I do with it? What's the verb, the math verb? And then I get an answer. Okay. I missed the middle step. And then, so this is like the question as we are comfortable saying. And this is the answer. Like, this is what we would say looks like an answer. Well, what if I want to go from the answer to the question? What do I do? Okay, so this is the circle of math. Why is it a circle of math? Well, once I factor it, can I keep going? Yeah, you can expand. Once you expand, you can factor, expand, factor. So let's just say over the weekend, you're like, oh, really wish I had something to do, right? Well, you could take a question, expand it, then you can factor it, then you can expand it, then you can factor it, expand it. Guys, you could do it all day long. Just saying. It's wonderful. But all that to say, methods of expanding have a related method of factoring. Okay, let's start. Now, I'm going to give it my names, and we can write down whatever names you've used as well. So, starting with expanding, the first strategy or tool, I did this when I used to call it a strategy, but let's call it a tool because I think that's a better way of calling it. Name of strategy / tool. So the first one that we learn back in grade 9 is called the distributive property. I call it the rainbow rule because we make rainbows. Okay, when to use it? When you have a monomial times any polynomial, but it has to be a monomial, right? What are the steps? Monomial multiplies each term inside the bracket. And then I write this: number times number, letter times letter, like variable times variable. Okay? Let's do an example. So I call it the rainbow rule because this multiplies this, this multiplies this multiplies that. Okay? Now, the way that you can show it to me, you don't have to show what you're going to be multiplying. You can straight up multiply it. So I'll color this so you can see. So if I multiply the first arc, now for me, these kind of arcs imply that I'm multiplying. So I said number times number, 3 times -4, letter times letter, x squared times x5, x7, right? We just add the exponents. Next rainbow, 3x squared times 3x squared. Okay, well, I'm adding them, so it's plus 9x to the power of 4. Lastly, 3x squared times -7, -21. And because there's no other x variable, you just leave it as x squared. There's nothing else to do. You stop. Don't factor it. You were just told to expand. There's nothing to do. But that's factoring. Because look, that's where you came from. It's like you're going back to the question. Yeah. Yeah. All right, let's try another one. Okay, so once again, it's a monomial. So if I have a monomial, I'm just drawing an arc between the monomial and each term. Okay, negative times negative, so I get 8. Now, the x's multiply each other and the y's multiply each other. And so I'm just adding the exponents. X times x5 is x6. Y3 times y is y4. Folks, this is the time to ask clarifying questions, right? Because it's been a while. So, hey, Miss Sly, remind me how you got that. Second rainbow. -2 times 3, -6. Folks, if I have just an x, what's the exponent? Good. Okay, now please do not copy what I'm doing because that's a waste of brain space. Let's work in parallel. And then I wonder if this last one is
Please
confusing.
excuse the interruption.
Wow.
At this time, we will invite those staff and students who are scheduled to participate in assembly number 2 in Lismore Hall to please proceed now. Another announcement is we ask the teachers who have been issued board laptops, not Chromebooks, but laptops, to please drop off your laptop to room 120 for the Windows 11 upgrade. We ask that you please remember to label your unit with your name so it can be returned to you. Thank you.
And then here at the bottom, you can write some hints. So let's say you forget that x is the same thing as x to the power of 1, right? You might want to do that. Or if you want to be like, oh, x3 times x5 equals x3 plus 5, right? You could sort of put some steps there. Yeah, Maya. This is not your tool sheet. This is mine. So, folks, we've just talked about the distributive property. Second tool that we have in expanding is multiplying binomials. This could be known as FOIL. However, there's more ways to look at it. So when do we use FOIL? When we have two unique binomials, right? So on your tool sheet, if you'd like to, like, yes, you cannot use examples, but if you want to like write like a question like this, sort of to be like, this is an example of a question that you would do distributive property. This is an example of a question that you would do for multiplying binomials. You can write that, you just can't solve it. Okay, so what are the steps of multiplying two binomials? It could be FOIL. Who learned FOIL here? Okay, I actually don't like it because in grade 11, FOIL doesn't work when we start multiplying trinomials with each other. So I write, I just say multiply each term in the first bracket by each term in the second. So it's sort of like a double rainbow situation. So we go x times x, x times -9, right? And then we go 7 times x, 7 times -9. Pardon? I can't hear you. Say it out loud. That is FOIL. The reason why I've stopped teaching FOIL is that in grade 11, you're going to get a question like this, and FOIL doesn't work for that, right? But what does work is every term in the first bracket multiplies every term in the second bracket, right? So it's just, it works for more. All right, so let's work on these two examples. I will color code so that you can follow. This first step could be skipped, right? If you can do it in your head, go for it. Right? And the only thing that has to be done in your head is combining these two terms. Do we factor? Should I keep going and factoring? No, because what would the question have said? Expand and simplify. Okay, so I might, on my cheat sheet, write down, what does simplify mean? Anyone know? Yeah. Yeah, the simplest looking, make it at least the least complicated. Collect like terms is one piece of simplifying. Expand, a very simple definition of it is get rid of the brackets. Expand really means we're multiplying, but to say get rid of brackets, oh yeah, I'm going to multiply. All right, let's do one more example. Oh, actually, let's do example C. Okay, because sometimes students get confused when there are two variables. So the first term is just 5a squared. But now when I have to multiply 5a times 4b, okay, it's still number times number. And now I just write ab. And so the same goes for the next term. Negative 9 ab. Oh, like terms. Negative 36 ab. And then, so that step was called expand. The next step is called simplify. Yes, did I make a mistake?
Wouldn't it be b squared?
It is b squared. Thank you. 36b squared. 5a squared plus 11ab minus 36b squared. Stop right there. The teacher did not tell you to factor. This is fully simplified. Okay, you need to write down any hints, write down any hints. Moving on to the next one. This is my absolute favorite because I gave it a really good name. It's called the flow rule. And it's not FL. That's mispronounced. It's flow. The technical name is sum and difference. Folks, when I do a sum, which operator am I talking about? And what is difference? Subtraction. That's the really important piece. Sum and difference means there's a sum and there's a difference. I have two identical binomials, but one is a sum and one is a difference. Okay? And that's important because if you get two identical binomials, but no sum and difference, you cannot use this method. And so within FOIL, the F stands for first terms, and the L stands for last terms. So the reason why it's important to identify these, like, look, identical binomials, but one has a difference and one has a sum. When you have that scenario, all you have to do is multiply the first terms and multiply the last terms, and you're done. Right? These are my last terms. These are my first terms. So what do I get? 25a squared. Positive times negative is negative, minus 81b squared. So this is called sum and difference. But there is a factoring method that is related to this one. Flip your page and tell me the name of the factoring method that is related to this. Actually, I want everyone to point to it. difference of squares. How do I know it's difference of squares? Well, in my decision tree for factoring, if I have a binomial, there's only one method of factoring aside from common factoring. So in my decision tree, we're going to look at this later, but step one, for every single factoring question, you check for common factoring first. That is step one. And then you branch out looking at what type of polynomial. So if you have a binomial and you've already common factored, the only thing you could do is difference of squares. If it's not a difference of squares scenario, you can't factor further. So maybe in my hint, I would write related to difference of squares. If that makes sense for me, it makes sense for me, so I'll write it. How about if we look at the if we look at, what do we call this? Multiplying binomials. So if this is our answer, and if that is our answer, and if we were asked to factor, there are two methods of factoring that are related to multiplying binomials. What would be the method of factoring that we use for this upper trinomial? What is Miss Sly? Does Miss Sly have a name for it here? Oh. Right? It's simple trinomial. Related factoring. We've got simple trinomial. And what did you guys call it when you do decomposition? Did you just call it decomposition and grouping? Pardon? You learned decomposition. Yeah, so what did you call it? Grouping? Okay, but I'm going to write decomposition / grouping because you need to know that it's called decomposition because it's often referred to as that. I'll talk about that tomorrow. It's just 2 steps. It's like you first have to decompose before you can group. Because when you're grouping, you have 4 terms. So the first step is decomposing. Okay? So let's practice the sum and difference. Okay, so let's do these other 2 questions. And all you're doing is multiplying the first and multiplying the last. But what has to go in the middle? Which sign? What sign goes in the middle? Has to be the minus. Okay, so if we do question B, 3x times 3x, okay, that's 9x squared. -1 times +1 is -1, right? It's so quick. If you were just doing regular multiplying binomials, you would be doing way too much work. So it's important to recognize, oh, this is a sum and difference. I've got 2 steps, 4a times 4a, -5b times 5b, and that's it, right? It's nice and easy. Now, is it wrong to do multiplying binomials? No. But again, next year, you want to be as quick as possible. So you're not wasting space and steps. Last one. This one I would say is the trickiest. Square a binomial. My nickname for it is SAB. Square a binomial. This one is so important. And again, students keep forgetting to do it properly. And I'm going to show you the big mistake later on. Now, When do we do it? When a binomial is being squared. Okay. What are the steps? Square the first and last term. Okay, so let's do that. Square the first term, 2x, 4x squared. Square the last term, 7 times 7 is 49. I bet you my phone is here. Good morning. Hi. Oh, hi. Pardon? I am. How are you? Good. Isn't he wonderful? Oh, that's nice. Yes. Good. Excellent. I mean, I'll be there. I have prep next period, so I'll come down and get it. Thank you so much. Perfect. Okay, thank you. Bye. All right. So that's the easy step, I find. It's the middle term that is hard. Okay, so this is what I would put on my tool sheet. Yeah.
Maybe just put them into and then just
Multiply binomials? Yes, but I want you to practice the one-step method because next year it's important that you recognize backwards that you're like, oh, I have a perfect square trinomial and I can factor it into a squared binomial. That is really important for you to recognize that. Okay? So let's practice it. What do we do for the middle term? Multiply the first and last term, then double it. Watch this. Multiply these two and double it. So I go 2x times 7. What is that, everyone? Double it now. And because it's positive, it's plus 28x. One step. I want you to practice this. Be solid with it. Let's try it again.
and then for the last, it's plus 49, right?
Yep. Oh, yeah. There's a plus. Yeah. Okay, let's try the next one. Square the first term. What do we get, folks? Yeah, folks, I want everyone engaged. Square the first term. What do you get? Oh my gosh. I'm going to make you repeat it. Folks, square the first term. Good. Square the last term. Good. Because it's -1 times -1, so it's going to be plus 1. Now the ugly middle term. So watch here if you're not sure. Watch me. 3x times 1 doubled. So 3x times -1 is -3. Now double it, minus 6x. You can do this in one step, folks. You can do it. This is the time to learn it. Last one. Okay, you try it on your own. Don't be afraid of the double variables. It just means the middle term has A and B. Okay, 4 times -5 is -20. Doubled is -40 AB. Looks really complicated, right? So that's why it's important to practice. We good? So folks, that is a summary of methods of expanding. Okay. Let's go to, I think, do you want to do factoring today? Yeah, let's do factoring. Okay, so what is the first thing you do, everyone?
For the greatest
Yeah, I want to hear from everyone. Read the box. Okay, if my knee was not injured, I would jump off the desk and yell, check for wait, what? No, I go, always common factor, right? Always common factor first. If it's possible, do it every single time. There might be more factoring after that, but if you common factor, it always makes it easier. Okay, so that's what you always do. You always check for common factoring. You can call it greatest common factor, all good. We get what you're saying. Okay, now we have this tree. If I have a binomial, the only method of factoring that is available for me is difference of squares. So let's write some examples. And on your tool sheet, you could write examples of a binomial that will be factored using difference of squares. Okay, you can't actually factor it, but you can write, oh, it would be like 9x minus 4. It would be like 16a squared minus 25b squared. So what I see is that it's a binomial. There's two terms. There's a minus in the middle. And both terms, we call them perfect squares. Both terms are perfect squares. So they have a square root and minus in middle. So you could, in theory, write all of that on your tool sheet. Now I'm going to put an example which you cannot. So let's practice. Okay, so what are the steps? 2 brackets, right? We're going to have 2 brackets. Take the square root of the first term. So the square root of 9x squared is going to be 3x. And notice you put it at the front of both brackets. Take the square root of the second term. So 25, square root of 25 is just 5. And then one of the brackets gets a plus and one of the brackets gets a minus. That's where we get that sum and difference connection. Right? So this method of factoring is called the difference of squares. Well, guess what? This is a perfect square. This is a perfect square. And we're taking the difference of them. I'm going to give you 2 more examples. 3 more, actually. Okay, go ahead and factor this one. It's a one-liner, right? That's what's kind of nice. Okay, so be careful with the last 2. I added some tricks there. Okay, once again, step 1, draw 2 brackets. Step 2, take the square root of the first term, take the square root of the second term, and then one of that gets a plus and one gets a minus. Now tell me what's the problem with C? Why can't I straight up do it? Yeah,
32 is now by the square.
it's not a perfect square. How about 200? Is it a perfect square? No. How about the variables? Are they perfect squares? Can I take a square root of them? So what do I do? Look at your whole chart. What should I have done first? What is the greatest common factor of this expression? Oh yeah, it would does 8 go into
Yeah, 200 divided by 8 is 25.
Oh, perfect. Okay. So it's going to be 8. What else? What's the variable that they both share? Good. Okay. So now let's see what happens once I factor out the common factor. I get 4y squared minus 25x squared. Oh, do you see? Do you see what popped out there? Can I keep factoring? Yeah, I can. Okay, so the 8x stays there. And now I see that what I have in the brackets is, in fact, a difference of squares. So I take the square root of the first term, 2y, and I put it at the front of both brackets. Then I take the square root of the last term, and I put it at the end of each bracket. And then what do I put in the middle of the two brackets? Say it out loud. Minus plus. Could it be plus minus? Yeah, it doesn't matter. So that was tricky. There were two methods of there, but I saved myself because I common factored first. Woohoo! Why is the next one a trick? Okay. Talk to the people around you. What is the trick? All right, folks, what's the problem? Yeah, there's a plus sign. So what does that mean? Nope. There is no common factor.
Can't you just put like 7x plus 9
Let's check.
in the bracket and then
And then what's the other bracket?
same thing? You just put the square root.
Okay, so don't write this, but let's test it, right? So basically we want to see what it's like to square this binomial. Okay, so when I square a binomial, I square the first term, I square the last term, and I multiply the two terms and double them. So 63 doubled is 132x. So can I factor 49x squared plus 81? No. Good. So I'm really glad you asked that, right? Because it's a very common mistake. People are like, yeah, of course you can factor it. No, you actually can't. All right. Do you get 10 points? How many do you want? 10? Sure, take 10. Very generous today. All right. Next. So I did my common factoring. Now I've got a trinomial. There are 3 options. Okay. You can always use decomposition and just get it. But folks, it's about being efficient. And again, in grade 11, if you are doing decomposition on simple trinomials, you are wasting so much time and you won't finish your test. You don't have time on the first test to do decomposition. You're going to factor 50 times on the first test. So you just want to be able to factor like this. So it's important that you recognize when to use each of these factoring methods. So when do I use simple trinomial factoring? Well, I use it when a equals 1. What does that mean? What is my acceleration factor? 1. If I have an expression like this, it is a one-liner to factor. Do not decompose. You cannot. I can't stress it enough. If you enter functions and you are using decomposition on this trinomial, you're going to stumble, folks. So how do I know to use simple trinomial factoring? Well, a is 1. How do I do it? I draw a plus on the middle term, a times on the last term. I look for two numbers that add up to 6 and multiply to 8. Right? You can still do your table. Did you write R and S? What do they stand for? The roots. Okay, those were the two roots. So so in factored form, we write y equals x minus r, x minus s, and s and r are the two roots. Don't know why they chose s and r, but that's where this table was coming from. Okay, so we're looking for two terms that multiply to be 8. Okay, it could be 1 and 8. It could be 4 and 2. And that's it. Which ones are they? Because they have to add up to 6, 2, and 4. So remember, so then one step, folks, do not decompose. An x goes at the front and the two roots. Come on up and grab a sheet. And the two roots go in there. Folks, one step. Do you see that? Okay, and then there's 3 versions of simple trinomials. The second version is when your last term has a minus. So that means, okay, we got to multiply 2 terms to give me a minus. How do I, if I go something, so when I multiply 2 numbers and end up with a negative, what are my 2 numbers going to be? Positive and negative. There has to be 1 positive, 1 negative. Okay, now I make my table again. R and S, they have to equal to 20. So 1 and 20, 2 and 10, 5 and 4. Which one of this, given that one of them is a negative, will give me 8? Well, it's going to be 2 and 10. Which one, it's for me to get negative 8, which one has to be negative? Do you see how quick that is? One step. Last example is when your middle term is negative. Let me think of something. But your last term is positive. So when I see that, now watch this. Do you see how I just put the x's in front? If I have x squared, where a is 1, I know that the first terms are going to be x. So now all I have to do, like, you don't even have to do the table because whatever you get from the table goes into these brackets. But let's do the table. right? But I don't require you to do this table. 42. I've got 1 and 42, 2 and 21. How do you do the table then? When it doesn't divide into 21 by 2? Do I divide it by 3? 7 and 6? I'm not sure how the table worked.
Oh, yeah, you just go,
If I divided by 3, I times by 3?
oh, you just wrote all the
You just wrote all of them. Got it. Okay, cool, cool. And I see that 6 plus 7 is 13. Okay. Now, in order to get a positive product, I could get positive times positive or negative times negative. And in this case, it has to be negative times negative because of that middle term. We get this? Isn't it easy, folks? Like a one-stepper, it's beautiful. Yeah. All right, so let's go to decomposition first. So when A does not equal to 1, so that could be like, oh, I need it. It could be like 2x squared. I'm making, no, take that back. Sorry. I need to invent one in my head. This is a hard one to do. 4x squared. 16 minus 3. Yeah. All right. So what is my A value in this case? 4. Okay, it's not 1, so I have to go to decomposition. Okay. And so in this case, again, we're making that table. But this time, I have to multiply these two terms, the A and the C, to find out, right? I have to multiply A times C. So 4 times negative 12 gives me negative 48. Okay, let's see. And let's see what will give us negative 13. So I could go 24 and 2, 12 and 4, 6 and 8, 48 is also 16 times 3. Well, that one will help, right? 16 and 3. Okay, so watch the colors. What's not changing? 4x squared and minus 12 are not changing. But this is what decomposition is. This step here, when I take the middle term and I break it up, right? When food is decomposing, it's breaking up. So this step is called decomposition. So I'm taking that negative 13 and I'm breaking it up into 16 and 3. The 16 has to be negative so that I get negative 13. So if you want to give it a name, this is decomposition. The next step is called grouping. Right? So who cares what it's called as long as you understand that it could be called grouping or decomposition. And so here, we group the first two terms, we group the last two terms. We find their common factor. 4x squared and 16x. Okay, there's a 4x. We're left with x minus 4. Common factor of the second term, just a 3x minus 4. And then we common factor again, right? So we say, oh, look at that. Both terms have an x minus 4. And then what's left over? Nice. 4x plus 3. How many steps does that take? This whole process? 3. How many steps does simple trinomial factoring take? 1. So if you can, avoid decomposition. Okay? So you might make some notes for yourself here. Now, going to the middle one. Perfect square trinomial. A could be 1. A could be something else rather than 1. A perfect square trinomial, i.e. a PST, this is going to be related to SAB or square binomial. Related to SAB, which is square a binomial. Except because we're factoring, we're going from a trinomial to a binomial. So let me give you an example. X squared plus 10x plus 25. So once again, in grade 11, you kind of have to know to recognize these, especially once we get to unit, especially once we get to unit 8, when we do trigonometric identities. It's important that you it's important that you recognize PSTs, perfect square trinomial. How do I recognize it? Well, first and last term are perfect squares, right? They can be square rooted. First, last terms are perfect squares. This is usually a good enough indicator. I would say 90% of the time, if the first and last term are perfect squares, you've got a PST. So how do I deal with this? Well, watch this. I'm just going to have one bracket, and it's a one-stepper. Take the square root of the first term. What's the square root of x squared? It's just x. Take the square root of the last term. Well, that's just 5. And then I need to put a plus or minus here, so that's when I look at the middle term. Whatever my middle term sign is, that's what goes inside the binomial. That was crazy easy. Well, I don't know about easy, but fast. Let's check, folks. Sometimes I'm like, I don't know, I don't trust this. So let's check. Do you remember we had the square a binomial steps? Square the first term, x squared. Square the last term, plus 25. And what do we do with the middle term? If you forgot, flip your paper and look at it. I'm looking at square a binomial. Middle term, multiply first and last, then double. Oh yeah, multiply first and last and double. X times 5 doubled is plus 10x. Does it work? Yeah, it's a PST. So you don't have to check it, but that's how you check if it truly is a perfect square trinomial. Let me give you another one. I'm going to give you 2 more examples to practice. Okay, go ahead and factor that one. So let's do it in one step. I'm drawing my bracket, I'm squaring it. Good luck, Miss Sly. Take the square root of the first term. Take the square root of the last term. Put the middle sign in. That was nice. I'm looking at this trinomial and I notice I got 25 and 4. Ooh, the first and last term are perfect squares. I wonder if it will work as a binomial squared. Is it a PST is the question. Is it a perfect square trinomial? 4b squared, well, the square root of that is 4b. If it's true, I'll put a minus in the middle. And now I'm going to check that middle term. 5a times 2b is 10ab doubled. Oh yeah, it works out. Tricky, but really efficient. Okay, last factoring method, which really is part of decomposition, is just factoring by grouping. This is hard to make up. Okay, so we're gonna have, so when do I use factoring by grouping? What kind of polynomial do I have? 4 term. Okay, is there anything else I can do? Yeah, of course. You're gonna check for common factoring. But once you've done that, the only other factoring method you could use on a 4-term polynomial is grouping, right? So here's an example. I'm going to have 10x squared. Oh, this is a nice one. Okay, go ahead, factor by grouping. Put them in 2 groups. Factor out the common factor. What am I left with? 5x plus 3. Should I ask them to speak a bit louder? Okay, folks. Second set of 2 terms. What's the common factor? Is it 1 or -1? Yes, because otherwise I won't get 5x plus 3. So I have to factor out the -1 so that both of them become positive. Now, you might sometimes get a 4-term polynomial where where factoring by grouping doesn't work, right? So you might just common factor and that's it. Okay, is this a helpful tool? Yeah? Okay, so again, you can copy as much as you want of this onto your formula, onto your memory aid, as long as you don't put examples.